Namaste and welcome back to the DSA classes. Today we are going to be solving another very commonly asked question, especially regarding recursion, called as the Tower of Hanoi. Now, Tower of Hanoi is a game which probably many of you have played, right? Even if you have not, we are going to be playing the game and understanding how to play the game. Anyways, what is this Tower of Hanoi problem all about? First of all, what is this Towers of Hanoi, right? Very simple. See, there are three towers like this. Assume there are three towers. Okay. Now, you will be given an n value, guys. Let us assume n is 3. Now, n can be any value. Let us assume n is 3. What it means is that in this Tower of Hanoi game, you have 3 discs. That is what it means, right? So, this is Tower A, Tower B, Tower C. And you have 3 discs like this. The ultimate aim of Tower of Hanoi problem is to move all these 3 discs from the first tower to this last tower. That is the ultimate aim of what you call as Tower of Hanoi problem. But you may say very simple, take these 3 discs, put it there. It's not as simple as that, guys. There are certain rules. What are the rules? I will tell you. But ultimately, as I told you, the aim is to place it in the last tower. That is the aim. Anyways, let me bring it back. Now what you must understand is what are the rules, right? Because you have to move it. For the movement there are rules, especially there are 2 rules which you must keep in mind. Rule number 1, only one disc can be moved at any given point of time, which means I can't take these 3 discs and move together, or I can't take 2 discs and move together. At any given point of time I can move only a single disc. I hope this is clear to all of you. The second rule of the problem states that a larger disc cannot be placed on a smaller disc. I repeat, a larger disc cannot be placed on a smaller disc. I hope everybody understood this problem, right? Which means I cannot be taking this disc, placing it here, and taking the larger disc and placing it on top of it. I cannot do that. Only a smaller disc can be placed on a larger disc. So keeping these 2 in mind, how would you solve it? Very simple. I am showing you the most efficient way to solve it, right? The most efficient way to solve it is first take this small disc and shift it to the last disc. I have followed the 2 rules. I have shifted only one disc at a time. I have not placed a larger disc on a smaller disc. In fact, this is the only disc, right? So the first move is move A to C. Second move I will do is move this to B. Move this to B. So that is what I am also showing, right? From A to B I have moved. Next what I will do is I will take this smaller disc, place it on this larger disc. Great. So what is the move? C to B. Next, this is free. So what I will do is I will take the larger disc, place it there. So what is the move? A to C. Any confusion? Next what I will do is I want to place this larger disc here, but this smaller disc is there. So what I will do is I will place it here. Clear? Which means now what is the next move? The move is B to A. Any confusion? Great. Now that this disc is free, I can move it and place it here. So what is the move? B to C. Any confusion till here? And finally, I will be moving A to C. And that is what I am showing. Finally, move A to C. Any confusion? So totally 7 moves. 7 moves you are able to complete it. Any confusion till this point of time? Now, the aim is to solve this problem using a program. The aim is to recursively solve this problem. How can you write a recurrence relationship or a set of calls to functions which call themselves such that you can solve this Tower of Hanoi problem? If you ask me, it's very, very simple. Let me show you. Guys, now what I'm trying to say is, let me just bring the Tower of Hanoi problem again to you. Now, this is the problem where n is 3. N discs have to be moved from this source to destination, from A to C ultimately. So, how I will break this down into a smaller problem is, I will say, hey, what if I tell that I have 3 discs, but what if I'll break this down into a smaller problem and I will tell, what if initially I will try to see how to move these 2 discs, these n minus 1 discs. If there are 3 discs, leave the last one, n minus 1 dis. So 2 dis, how will I basically shift that n minus 1 dis from A to B? That is what I will check. So see here, like this I will tell, n minus 1 dis I have. Now this n minus 1 dis, what I am trying to do is I am moving it to B. Any confusion till here? So now, from somewhere it started, somewhere it ended, and there was one more thing which was not being used. Would you agree with me? Now, whichever one you are starting with is called as source. Whichever one you are moving it to is called as destination. Whichever one you are not using is only called as auxiliary. Any confusion till this? So these are terminologies which they use in solving it. So what I would say is, here A is source, B is destination, C is auxiliary. Any confusion till it? So see, the large problem was to move 3 disks from A to C. I said, hey, why 3 disks? 2 disks, n minus 1. 2 disks, I will see first how to move it here. Now, if I successfully move these 2 disks here, then I have only 1 disk remaining. Now, naturally tell me, where should this 1 disk go? This 1 disk should come and sit in C. Would you agree? This is the only disk that is remaining. Which means, that is what I am also showing you. This 1 disk from A to C it should go. So it started from A. So A is only the source. It went to C. So C is the destination. The one which was in between which did not get used is B. So B becomes auxiliary. Any confusion? So you have source, destination, auxiliary. The towers in different moves will play different roles. Sometimes source, sometimes auxiliary, sometimes destination. It depends upon which move you are making. Any confusion? Now very simple. N minus 1 disk first you moved here. 1 disk you moved there. Now n minus 1 disk, if I moved here, problem is solved. So that's what I am also saying. These n minus 1 disks, if I take these n minus 1 disks and if in case I moved there, problem is solved. So if moving there means what? Source, destination, auxiliary, and that is what I am also showing. Auxiliary, source, destination. Which means a tower of Hanoi problem which had n disks, I have broken it down into 3 sub-problems, where first I move n minus 1 disk, then I move 1 disk, then I move n minus 1 disk. Would you agree with me? My friends, this is only your recurrence relationship. What do you mean, sir? You may ask. Very simple. What if I write a function called as tower of Hanoi, which will initially take n, the number of disks as input, and will take 3 values, A, B and C. Now, you know initially these 3 disks will be here. They have to move here. So, this is source, that is destination, this is auxiliary. Would you agree with me? So, source, auxiliary, destination. So, I will have 3 variables, source, auxiliary, destination. Initially source is A, auxiliary is B, destination is C. However, to solve this, I can break it down into 3 sub-problems. See, that's what I am also showing. But I can break it down into 3 sub-problems. What are the 3 sub-problems? First problem is, n minus 1 disk, you please move to B. N minus 1 disk, move to B. So see, this was source, this was auxiliary, this was destination, isn't it? Anyways here, A is the source, okay, so initially source is right here. Next one, destination became B. So see, at the place of destination, B came. Then auxiliary was C. Any confusion till this point of time? Anyways, further one that I have, that I should move from A to C. So see, 1 move from A to C and B becomes my auxiliary. And then finally n minus 1 disk should be moved from B to C, A becomes my auxiliary. So what I am trying to show is, I am showing the source, destination, auxiliary. Auxiliary, destination. And this is auxiliary, source, destination. Now what does this mean? Why have I written it like this? Simple. Initially to the function, you pass 3 values. First value was collected in source, second value was collected in auxiliary, third value was collected in destination. Which means A is inside source, B is inside auxiliary, C is inside destination. But sometimes A is auxiliary, B is destination, C is source, it keeps changing. So what should I do? I should just rearrange these variables. So see, first call, A is only source. So see, source is in the first position, right? Now C is your, B is your destination, B is your destination. So B was inside auxiliary, so auxiliary came in the end. C is destination, C was inside destination, but it should act as auxiliary, so I passed it in between. So just by rearranging these variables and calling, I have achieved it. But ultimately A is inside source, B is inside auxiliary, C is inside destination. If I want A to be at source, I will pass it in this position. If I want C to be an auxiliary, I will pass it in this position. If I want B to be a destination, then aux I will pass in the last position. So by rearranging matter is over. Similarly, see here, A, B, C I should get. So how should I pass? Source, aux, destination. BAC I want. If I want BAC, how will I pass it? B is inside aux. So aux first. Then A is inside source. So source second. Then C is inside destination, so C third or destination third. So please understand, in the function call, this will be the signature. Initially A in source, B in aux, C in destination. Rearrange it and send it so that this can be achieved. I hope everybody understood whatever I am trying to tell. Now let us see whether this recurrence relationship can actually work. To check that, what I am trying to say is, I am just removing that ABC. Ultimately, it will look like this. Ultimately, it will look like this. Any confusion till here, guys? Beautiful. Now, let's go and try to create a recursion tree to see whether it will work. So, these are my 3 towers. Initially, I have 3 disks in A. I am bringing up the recurrence relationship for all of you to see. These are the moves which ultimately I should make. Now, when I am solving this, I want you to focus and try to identify the base conditions. What could be the base conditions? Let's explore. So, first time when I call, this is how it would look like. N, what should be the N value? 3 disks are there, so I will pass 3. Next, for source, I will pass A. To auxiliary, I will pass B. I am writing it as A because of lack of space. For destination D, I will pass C. So A, B, C, correct, A, B, C. A to C. So source, destination, auxiliary. Source, destination, auxiliary, destination. Any confusion till here? 3 this. Now, further inside the function, you will make 3 recursive calls. For n minus 1, 1 and n minus 1. Would you agree? Now for n minus 1, how is it going to work? That is what I am showing. So first this call will get. So n minus 1 means 3 minus 1. N will become 2. So you are talking about these 2 disks. And see, I am showing that here. Only 2 disks are there. Here 3 disks, here only 2 disks. Any confusion? Next, what should be inside S? What should be inside A? What should be inside D? Now see here, n minus 1 means this is source. This is destination. This should come here. This is destination. That is auxiliary. So you have to rearrange it and send. If I rearrange it and send, then see correctly those values will come and send. And I am showing just this. So I am just showing this. So see, source is in the first position only. So A will come. What is there in destination? So C will become auxiliary and D will become destination. Just by rearranging and sending, you got the required effort. Any confusion? Now, again you call this Tower of Hanoi, which means again inside 3 recursive calls will happen. So 3 recursive calls. N minus 1, 1 and n minus 1. Which means if I wanted to move 3 disks here, first I said I will move these 2 disks here. Then I am saying here, I will move this 1 disk here. That is what I am saying. So if I say n minus 1, again n becomes 1. Now, again this call only. So source, now see here, again source, destination, auxiliary. What is there inside source? A. So as it is, right? Now whatever was there in destination has to come inside auxiliary. What is there in destination? B. Whatever is there inside auxiliary should become destination. So C. Would you agree? So ultimately A to C it should go. And that is exactly what happens. A, B, C. Now my friends, you can see n has become 1. If n has become 1, it means you are now, see this only one disk I am showing you. It means to say that now you are working with 1 disk. So ultimately it was 3 disks, then you made it as 2 disks, then you made it as 1 disk. Now it's 1 disk you can move. And where should you move it from? Source to destination. What is source? A. From A to C you have to move. This is only your base condition. So the moment n becomes 1, you hit your base condition. And if you hit your base condition, I will tell, hey, please move from source to destination, which is nothing but move from A to C. And if I do that, from A to C I will move. And also here I am showing the moves. I moved from A to C. Correctly it has worked. Any confusion? You hit your base, so return. After returning, now comes the next call. So that is this. That is what I am also showing you. So this one. So n is 1. Then source, aux, destination. So A will be the source as it is. Aux should become here. So what was there in aux was C. So C will come here. Destination B, B will come here. So that is what I will get. A, C and B. Same as that. Again n is 1. If n is 1, you hit your base condition. If you hit your base condition, please move from source to destination. That is what I am also showing. Please move from source to destination. If I move from source to destination, I am moving from A to B. I am correct. If I move from A to B, this disk is going to come and sit here. And that move I am also just writing it here. That I should move from A to B. 2 moves done, totally 7 moves. Let's see how it works. Base condition, return. Once I return, next call, n minus 1. So see, that's what I am showing. N minus 1 means 2 minus 1, again base condition, n becomes 1 and that is this call. So see here, it's aux, source, destination. What was there in aux? C, that becomes source. What was there in source? A, that becomes auxiliary. And what was there in destination is B, that remains as it is. So that is what I am also showing. C, A, B. So ultimately, you must move from C to B. Correctly it is working. So I have hit my base condition. If I hit my base condition, I will move from source to destination. If I move from source to destination, it is nothing but moving from C to B and that comes here. And that is what I am also showing as a move. You see perfectly it is working. You hit a base condition, come back. All 3 calls have returned, come back. Once you come back, now you are here, n minus 1 is over, 1 and this is that 1. N minus 1 you moved successfully. Now this 1 is remaining. So there obviously n value is 1. So I am coming back to this call. See this call. Okay. So source, aux, destination, ultimately A to C. So as it is, it will pass because the order is that. You can see. So I will move from A to C. That is because I have hit my base condition. I am now going to move from source to destination and which is nothing but A to C. I will move there and I am putting that move as well. Any confusion? Return. Next I will come to n minus 1. If I come to n minus 1, 3 minus 1 is 2. Now what should be the source, what should be the auxiliary, what should be the destination? So I am coming to this call. As you can see, whatever is there in aux should come to the source. Similarly, whatever is there in source should become aux. Similarly, what is there in destination should remain the destination and hence that is what I am showing. BAC. Move from source to destination. Ultimately you are saying I want to move these to this here. But directly you can't move. Don't worry. We will again break it down into smaller problems. N minus 1, 1, n minus 1. N minus 1 means it will become 1. And obviously this time this will call. Accordingly the values will go and sit. So it becomes BCA. So from B to A I should move. Correct. From B to A. B to A I should move. Yes, that is what I will also do. So base condition, move from source to destination, move from B to A, and if I do that, that comes here. You have hit a base, so return. Once I return, I will come here, next call, that is for N1. And obviously, automatically adjustment will happen, values will get passed. I should move from yes to C. I should move from B to C. Any confusion? And that is what I am going to do. So source to destination or B to C, and if I do that, it moves there. And I am also just noting the move down there. I am within a base condition, so I will return and I will come to n minus 1. N is 1, so again this is a base. This will get called. Automatically you will pass the variables in different order, whatever has to come in source, auxiliary and destination. So I will move from A to C. That is what I am saying. So source to destination, A to C moves. Perfect. And that is what I am also just showing the 7 moves. Return. Return. It's done. Ultimately, you would have printed this. Yes, you will be printing this. A variable thing. But I hope how to recursively break it down is clear to all of you. How as a recursive function it works is clear to all of you. And why we have split it into 3 recursive calls in every level is also clear to each and every one of you. Now if this is clear, all that is left is for us to go and write the code. And most importantly, what is the base condition here? Whenever n value becomes 1, just you have to print whatever is there in source, one arrow mark to destination. That's it. I hope you're able to think. Great guys. Now that you understood, let's go write some code. Alright, now it's just time for us to code. The recurrence relationship is ready. So as you can see, I've created a function called as tower of Hanoi, which will now accept 3 values from me. Right? So one integer n, which is the number of disks. Next is, so the source aux destination is A, B, C. So they are nothing but characters, isn't it? So I'll create 3 character variables. Char source, next char aux, and char destination. Right? Great. You can put T as well there, DEST. Great. Now inside this, first the base condition. So when do we hit the base condition? When the number of disks becomes 1. So let's do that. If in case n value is equal to 1. In that case, what should you do? Some of you will say return, correct. Before returning, you must print. So I'll tell system.out.println. And there, what should you print? Source to destination. So see, source plus, and within double quotes, I'll put one arrow mark like this. Okay, then yeah, plus to that I will attach the destination. So A, then this will come C. Now it is good. Next I will return. So that pretty much is your base, friends. Next come down and here we have to now make 3 recursive calls. So that's what I'm doing. So I'll just tell tower of Hanoi, again I will call it, and this time it will be source destination aux. n-1 source destination aux. I'm just writing the same thing, nothing new. Cool. Duplicate that line, and this is now for 1. So it is source aux destination. Yeah. Again, I'll just duplicate the line. Now it is for n-1 and it is aux source destination. Yeah. Last one remains the same. Beautiful. Will this work is the bigger question. Let's just go down to our main function. Let's call tower of Hanoi, and what I will do is n value is 3 disks. Next, I want to pass A as my first disk character, A, B, C, that I will pass. So source, auxiliary, destination, initial. So ultimate aim is to move all 3 disks from A to C, correct? Okay. Now, if in case I were to execute it, so if I execute it, clearly one can notice A to C, A to B, C to B, A to C, B to A, B to C, A to C. 7 moves. Perfectly it works. Any confusion till here? I hope you guys enjoyed this problem. One of the most commonly asked questions in recursion, but if you go and explain to the HR the way I did, I'm sure you will walk out with an offer letter. Anyways, I will catch you in the next class. Take care. Keep coding.